Then we get going. All right there. Well, thanks to you three joining us in the large audience. Luckily, it's not, maybe it don't get so hot if we're not overcrowded. My name is Morne Erasmus. I am doing the global direction for CommScope Smart Cities. We are an infrastructure provider, and we look after connectivity and all kinds of stuff. And what I want to talk to you today about is connectivity as the fifth utility. Got about 50 slides here, 10 minutes. We're going to go fast, very visual experience. But we'll talk a little bit about what is smart spaces, how do we see that, some of the trends we're seeing in the space of connectivity in our buildings, in our cities, and then wireline technologies, wireless technologies, and convergence. That's really when we become smart in our buildings. And the way we look at it is, if you look at this picture, in the middle you have a building, which we want to make smart, and then if you have multiple buildings, is the campus environment, either from a hospital, healthcare, corporate campuses, those kind of events, and then the macro layer, the city layer, the data center, the train station, the airports. How do we bring all this together? Because at the end of the day, it all needs to be connected. And what we as a company, CommScope, do is we manufacture category cable, Cat 5, Cat 6. Every 3 weeks, we make enough to go around the earth. And we sell it in 140 countries. We make fiber optic cable, the connectivity for fiber optics, wireless systems, license, cellular, DAS systems, small cells, and also wireless, Wi-Fi, Ruckus Wi-Fi, if you ever heard of those. We own that product. And then IoT, how do we converge IoT on that? And what we see today in the building is, in the world, there's this shift from the urban population is moving into highly dense rural areas, or the rural populations into urban areas. And we really hit an inflection point here a few years ago where there's more people living in cities now, and that creates a tremendous amount of problems. From your environmental, your parking, your safety, security, a host of them. And we believe with connectivity and with technology, we can help solve that. But the way to look at that is really through connectivity as your fifth utility. Water, gas, electricity, sewage, and now connectivity. We need to plan for it and build it in upfront. And that's where we want to help our customers with. So the way we connect today, welcome, is firstly through cellular connectivity. 4G, 5G, LTE, onto the cell tower in our buildings. Next is private networks. Very big in the US. We started rolling out CBRS. And the rest of the world is kind of looking at that on spectrum reuse. And then we moved on to IoT. You're all familiar, that's why we're here this week. How do we bring IoT into this equation to small cells potentially on poles? And then lastly, Wi-Fi. From your phone to your watch to your tablet, everything's got a Wi-Fi radio in it. That's how we bring it online. On the outside, but also on the inside. If you look in our buildings, stadiums, venues, how do we connect this? And the whole idea is to connect the edge to the cloud. How do we bring ones and zeros from the edge to the cloud? And for that, you need a tremendous amount of backhaul connectivity, copper and fiber. And that's how we see the world in our spectrum through our eyes. If we look at what happened here over the last few years, digital, everything is digital. When last have you opened up a phone book or watched a VHS, I can't remember what it is, a beta or a VHS tape? It's all on-demand content, digital content. Then mobile, we've got about 8 billion people in the world. There's more than 5 billion cell phones. And then the last one is this whole mobility platform, IoT. Today they estimated about 30 billion. In about 2 years from now, we're going to be at 70 billion. It's going to more than double within 2 or 3 years. How is this going to be sustainable? We can't replace 70 billion batteries in 5 years. We need to think of a sustainable way to do this. The other one is the trends in the enterprise. We see our corporate customers, very large campus builds, are migrating down and says, hey, more satellite offices. I get more talent, regional talent into more satellite offices. We're looking at hybrid workplace, where we're saying, hey, we want to work 2 days in the office, 2 days remote. How do we support that? Return to the office. Number one is safe return. How do you do a safe return? And for that, you need digital technologies to help you with that, to bring that safe return to your office. And then lastly, our cell phones is now our desk phone. If you return back to your office and you don't have cellular connectivity, I can't go to my office. As a salesperson, how do you make a phone call? So that technology refresh has to happen. and we want to help our customers with that. So let's take a step back. What's the evolution of networks? We had wireline, then we had wireless, and then we have IoT. We're in that physical layer of connectivity, but the next one is, what do you do with the data? Now that I have all this data and a data reservoir, data lakes, what can I do with the data? And this is what excites me, is this whole service layer, where it comes out now, you can now build services out if you have all this data. So let me give you some examples. Outside in the parking lot, you've got a camera on a light pole looking at, hey, green and red dots, where is my parking? Then I can take that data real time, and now I can say a digital layer in my building, which of my assets are overutilized, underutilized, how do I bring this to the table? And I know where to do my assets. But the next step is to integrate that with digital services like a wayfinding app, direct people and behavior to where you want it to be. Contactless payment, automated payment, traffic alerts, safety and security. We can integrate those services. We can build on this digital platform. And that's really what IoT enables us with. Another example is in Singapore. If you've ever been in Singapore, in the metro stations, we have a service provider that want to offload. When everybody goes in, they play their videos, and it overwhelms the cellular network. So they said, let's install Wi-Fi to offload video content. But now that we have that video content, you can actually see where people are moving with their mobile devices. And with that information, they start scheduling the trains. And now they can schedule trains more efficiently because they know when people are there without having the privacy concerns and issues with video facial recognition, purely from wireless offset. The other thing that we see a lot now is the shift to what we call critical infrastructure. Imagine Monday morning, you show up at your office, and you tap your key card to get into the door, the access control. It doesn't work. Who do you call? Do you call your technician? Do you call the electrician? Do you call IT? Do you call your security company? You send 3 trucks out because you don't know where the problem is. Well, what if we have technology that can say somebody touched the network and the network is offline? We can triage and bake for faster recoveries. And that is where we see now this edge applications. You have, say, a camera, one edge device doing multiple applications. Facial recognition, we got thermal scanning, we got people counting, we got hot desking. You have one edge device, the camera, doing many things. Now the customer is asking, whoa, this is a critical network. I lose that one camera, I lose all my applications. So what can I do to make this network more secure? And they're asking for battery backup. They're asking for redundant feeds, connectivity, failover processes. So it became a critical infrastructure link. And I think that's where a big shift is happening in our intelligent buildings. It's not just about connecting things, it's about how they secure and redundancy built into it. Then we talk about the next big thing is our physical security. Hey, we're one hack away from somebody plugging into your network and getting access. Can you monitor that? Automated infrastructure management. How can we control what is connected where? That helps a lot with this. And the whole idea here is our mission is really to connect smart communities, to live, work, and play. And it's everything from the smart pole to the digital kiosk to the parking station to charge your electrical vehicle. How do you connect all these devices smoothly? Because if we don't plan for this, this is what's happening in our cities today. And the communities are pushing back. Not in my backyard, I don't want this. So we need to come up with creative solutions around this. And we believe it all starts from a bottom-up approach. If you look at this diagram, people love to build a parking application and then a gunshot detection or then security applications and standing these up multiple silos. We're saying have a different approach. Come up from the bottom. Do a platform of connectivity, wireline and wireless with power. Do not forget the power. We don't want to deal with 70 billion batteries in 5 years. It's not sustainable. How do you build a connectivity platform with power and then you drive your applications on top? Because that's expandable. And to do that, we have a couple of different technologies for this. One, we start with wireline. There's 3 types of wireline connectivity. Copper, most cost-effective, drive power to your edge device with PoE. You have fiber, high bandwidth, high density, You can run fiber networks throughout your building longer distances. And then the best of both worlds, hybrid cables, where we now actually infuse copper with fiber in the same cable. So you can power and communicate over very long distances. PoE in our buildings, you're here in the building show. PoE is up to 90 watts now. Started at 15 to do a telephone. Now we're big screen televisions, LED lighting. We have so many more devices we're powering, and it's shifting to the OT side of the world, operation technology, where we're seeing today, you traditionally have your information systems, and now that business is driving with the operational systems. They're merging because my thermostat is online. My HVAC system is online. I need to merge these two and have a secure environment for them. And what we see as a connectivity provider, our cables that we used to plug stuff in the wall, they're saying, oh, that goes away. No, it's just shifting up into the ceiling because I have more wireless devices up in my ceiling now, from IoT sensors to smoke detection sensors to cellular to Wi-Fi to private networks. Everything is moving into the ceiling. That's what we're seeing. But also in the outside world, we talked about that hybrid cable. Imagine you want a camera on a light pole outside in the parking lot. Maybe it's more than 100 meters, so PoE, you can't use PoE power. We use these type of solutions. Now I can actually run up to 3 kilometers, potentially. The camera, the Wi-Fi access point. People want seamless connectivity everywhere. How do I take that edge device I'm trying to deploy, but with hybrid cables at much longer distances? So there's newer technologies that help us enable that. Next, don't forget about the brain. The brain of an intelligent society is our data centers. All the ones and zeros have to go somewhere. And from our large hyperscales, Facebook, Microsoft, those guys, to enterprise, to corporate, to multi-tenant, to MEC, mobile edge computing, how do we get lower latency, faster response time? We have to move the data centers back closer to the endpoints. And we're seeing a lot of that deployments happening now too for newer development. Shifting gears to the fun stuff, wireless. Everything today is wireless. The last connection is mostly wireless today in a mobile world. So there again, 3 things. Cellular connectivity, the 911, emergency 112 in Spain. How do you call business continuity? You need good cellular connectivity. Then you have your de facto, the free Wi-Fi everywhere. Everybody's always looking for free Wi-Fi. Good is not good enough anymore because business continuity on there. And then lastly, private networks, either in the form of the IoT or in private LTE networks like we're starting to see with spectrum reutilization. Like CBRS in the US, I know Europe has set aside some spectrum for that. And inside your building, you need to build a platform for these connectivity models. One, you need your Wi-Fi. No building is without Wi-Fi these days. You need cellular connectivity because people rely on their cell phones for highly secure business continuity. You need that private wireless that's coming out now that we're still trying to find the right use cases. Industry, there's big. In the medical field, there's a lot of those. Kind of the owner's network. You own your own devices, you own SIM cards. And then lastly, IoT. How do we build a converged system on this platform? That's really where it gets exciting for us. Inside our buildings, did you know 80% of mobile calls are made inside buildings? Did you know that? This is an old statistic, it's probably more now. Secondly, the more energy efficient we build our buildings, the more we block the RF signal from penetrating into our buildings. So we build these beautiful energy efficient buildings, but we can't get a cell signal inside. So you need technology to bring that signal inside of your building. 5G. No conference is ever done before 5G sings. Huge misconception about 5G. 5G is really the 5th generation of cellular connectivity. Simple. But not all 5Gs are the same. It promised this ultra low latency that we don't even know what to do with, but we can dreaming about doing a robotic surgery on a banana on the other side of the world. That's the only use cases we're coming up now. What we're really seeing with this is think a little bit about the 5th generation Prius, Toyota Prius. versus the 5th generation Tesla. It's about coverage versus speed. And that's what's happening in the 5G world also. It's all about this bandwidth. How do we develop on spectrum? If it's the low bands, it's very long distances. Mid bands, the range is getting shorter. And this holy grail of 5G is really only 100 meters. So now you need a small cell every 100 meters from where you are. So we're going from essentially these large macro towers to every second or third light post needs to be a deployment. And that's the same that's happening in the buildings. We believe that the coverage would be on low band, would be coverage, mid band for capacity, and then the ultra high band will be for very, very special applications because it doesn't penetrate through the walls as much. So that's a big problem. Now, don't forget about Wi-Fi. It's not just 5G. Isn't 6 better than 5? Well, we're at Wi-Fi 6 now. 6E is coming out. If you look at what happened in our homes the last 2 years, going from 10 devices to an average of almost 50 devices in a 4-person home. There's a tremendous influx here. And if you see what's happening with spectrum, with 2.4 and 5 gig, that we had 500 megahertz of spectrum, which is, spectrum is the oil of connectivity. That's how we get ones and zeros spread out through the world. With what's happening in Europe is with 6E, they released another 500 megahertz. So you double your spectrum with Wi-Fi 6E. In the US, it's triple the spectrum. So there's a tremendous opportunity for Wi-Fi in this space. And what you want to look at there is really, how do you converge this? How do you make it simple? From the switch that deliver the PoE power to your Wi-Fi access points, to your integrated APs with IoT built into them, to a software system that can manage and help you this with analytics and machine learning to help you quickly fault find where a problem is in your network. But also be aware of the technology cycle. This is where it gets a little tricky. If you look at how we change technologies, Wi-Fi 3, 4, 5, 6, 6E now, we're already talking about 7. Every 3-4 years, a new wireless technology comes out, Wi-Fi technology, the next generation. If you look at what's happening with switches, it's every 5 to 7 years. 2.4, 5 gig, 10 gig, 40 gig, the switches go up. So there's a mismatch in timeline. Then you add cellular. Cellular is about every 10 years, from 4G to LTE to 5G, 5G NR. And then you connect, you need connectivity behind this, which is decades. Nobody ripped their building out and refreshed the cable and fiber every 4 or 5 years. So you need to make sure that your baseline of connectivity is going to match your aspirations with your technology refreshes. And this is where a lot of people miss the boat, where you don't think about the whole spectrum, how the end-to-end connectivity in your buildings, and to bring that up. And that's happening on the outside too. If we look at what's happening in our cities, hey, I have to put 4G LTE out there on a pole. But then I also want IoT. Let's put a camera on the pole. And then they say, well, we got private networks coming out. You got Wi-Fi coming out. You got 5G coming out. And pretty soon, these poles in your parking lot, on your campus, in your cities, start looking like this. Mine is a crow. Here it seems like it's a seabird, one of this by the ocean. So people are pushing back on this. They don't want this in their facilities. They're saying we want a converged smart concealment system where it's modular, that we can build modular poles and add different technologies onto these poles. We're looking at kiosks, digital kiosks, that you put your technology, connectivity technology in. You're looking at smart street furniture that we can hide now on a signage, maybe some of our connectivity devices inside of that. And we're building more and more of this out. And this is happening in the cities close to you. If you look at the 3 here on the left, those are all the cellular poles, which is fairly large because you have large radio units in there. And in the 2 on the right is what we call our IoT poles, where you put maybe a camera and a Wi-Fi access point as an anchor tenant in the more aesthetically pleasing areas that people can enable your connectivity. So now that you see all from wire to wireless, how do we do this smarter and better? And that's really where we want to look at convergence, bridging the silos. Let's not go build it in silos. How do we build this smarter, not just more? And that's really in our building. We have too many networks today. If you look at voice, video, data, you have all these networks, disparate networks. How can we converge them? How can we take some of this stuff, the front hall, the back hall, the hardware? Where can we save and reuse some of these devices? And that's really what we want to help with. So to give you a simple example is, let's take in your building. Most of our buildings, intelligent buildings today, is going to have a Wi-Fi system. And then you build in that building, you need building automation. You put building automation, different gateway, different protocols, different system. Then let's stand up some smart lighting. Oh, let's add some security in there. No building is done without security. Let's build environmental monitoring in there. Maybe parking. Now, we love to sell you more infrastructure, but we don't think that's the smarter way to do it. You have a lot of bespoke systems here, a lot of different protocols, all talking different languages, different support needed. How can we do this better? And what we looked at is, you're going to deploy Wi-Fi already in your building. What if inside the gateway with the Wi-Fi, we add 2 more radios, standards-based Zigbee and Bluetooth. So you got now Wi-Fi, Zigbee, and Bluetooth built into your Wi-Fi access points. And then if you standardize on a standards-based platform, you can keep adding today and tomorrow to your different protocols, and we'll transport the data for you through a converged system. We believe this is a simpler, smarter way to do it, and not just build more. It's more cost-effective, more economical, easier to maintain, better security than multiple bespoke systems. And the whole reason for this, why it makes so much sense in our mind, is if you look at Wi-Fi is built for enterprise-grade security. I mean, every month or so you open the paper and there was an IoT hack somewhere. How often do you see the big Wi-Fi providers being hacked? It's enterprise-grade security, number one. Secondly, we talked about built-in IoT. Now we have hardware that's built in, so it's more cost-effective. And then lastly, build it on standards base. BLE Zigbee is a standards base, it's not proprietary. You've all seen what happened to Sigfox here recently, where customers build out on a very proprietary business model, and suddenly they're no longer in existence. And what's all the customers going to do? So build on standards. And then lastly, if you build a platform, it enables you to then go back in and now build recurring revenue services. Connectivity as a service. Now I can add, you want lighting control, you want environmental monitoring. A very simple thing like some of our MDU customers are saying, hey, a huge problem for me in high-rise buildings is flooding. It's a long weekend, a toilet overflow or a pipe break, and it's on the 10th floor and it drains the whole building. A small water sensor that I put behind the toilet or in the restrooms, $20. Runs over my Wi-Fi network, it let me know on my phone, hey, you got a leak, shut off the valve while you're laying on the beach with your family over a long weekend. That's the future of where IoT is going to take us, to help us enable these simple solutions. Who of you have stayed in a Marriott recently? Somebody, please. No? Nobody? Hey, we got one person. In the Marriott Hotel, your Wi-Fi access point in your room not only give you Wi-Fi to your computer and to your television, but it also talks to your door lock. So we're not building the door lock overlay systems, the thermostat overlay systems. All of that traffic runs through your wireless access point now. And then we look at multiple other applications that this enable, from energy to safety to access control. Now we can start reaching out on this. And this is really where we see it on the building side. You start with this, what we call the universal connectivity grid. We start in the bottom with copper to deliver PoE power to your end devices. Switches that drives that devices, fiber for the longer distances and higher backhaul, and then automated infrastructure management to manage all that remotely. Then on top on the left side, the unlicensed. Sorry, it's kind of high in the sky. The wireless, Wi-Fi, IoT converge onto the Wi-Fi. On the right side, your cellular, your licensed spectrum, either with distributed access systems like DAS, with small cell systems, or with private network systems, all into your building as a converged layer. And it's not just on the inside, it's also on the outside. these live, work, play communities where we have a stadium, then around the stadium there's a hotel, there's multi-dwelling, there's retail. These all come together as a converged network of our future. And this is what we believe make things smart. Because if you look at the human body, what makes us smart? Connecting our senses, our fingers, touch, taste, eyes to our brain. And that's the same with what we do in the network. We are that nerve system of connectivity, either by wired or by wireless, to help you connect the edge to the cloud. And with that, we believe in connected communities thrive, and it starts with the building, to the campus, to the cities. I thank you very much.